my name is Nicholas Wood. I spent the last 6 weeks working at Just Eat for my faculty project. But enough about me. This is Jean. Jean is a businesswoman who, surfing on the recent tidal wave of British optimism, has decided to start a new takeaway business selling classic British foods straight to your front door. But Jean has got a passion for cooking British food, but much less of a passion for setting up websites and payment systems. So for this, Jean goes to Just Eat. Just Eat is the largest takeaway platform in Britain. They connect takeaways and their customers. And one of the services that Just Eat provides to restaurants like Jean's is a menu transcription service. So Jean doesn't have to painstakingly type up her menu from scratch by hand. All she has to do is take a photograph of her menu, send it to Just Eat, and Just Eat employ typists who type it up for her manually and put it on the website. However, this process is manual and it comes with several quite high costs. The first is time. So each of these menus typed up by hand takes up to 2 hours for a final result. And this has implications for cost. With 1,000 new restaurant partners joining the platform every month, 250 days of labour is spent every month typing up these menus. And the third cost is the restaurant experience. So Jean might be raring to go starting her business, but sometimes she gets caught in a queue waiting up to 2 weeks to have her menu transcribed. So the question of the fellowship project was, can we automate this process using machine learning? So to answer this question, I designed a 4-stage pipeline. The first is optical character recognition, or OCR. The second is a machine learning classifier. The third is a structuring algorithm. And the fourth is a quality filter. And I'll go through each of these in turn. So first, optical character recognition. So as I said, Jean provides us with a photograph of a menu. But we can't use a photograph of a menu for doing analysis because it's an image. We need digital text, and then we can go on to do some more analysis. So to make this conversion, we use Amazon's text track service. It reads the image and gives us a text, a confidence, a height, and a position. So now we have given an image, we've now converted that into digital text. So now we know what the menu says, but we have no idea what any of it means. So we would really like to be able to know that a statement like starters is a category. Served with rice is a description. Fried chicken is an item. That would be really, really useful information. So to do this mapping, for the data scientists out there, I trained an XGBoost model using TiffyDiff embeddings to make this mapping, and we can perform this with 95% accuracy. So now we have a menu. We know what the text is, we know what the text means, and we need to put this all together into a final result. So we use a simple rules-based method to take each price and assign the nearest item and description and category to it. And we do this with every price on the menu, and we build up a final menu transcription. So we're done. We've got a final result. But the problem is that for some menus we do really, really well. For some menus we have strange structures and we do less well. And if we're going to bypass the typists and send the menus back to the restaurants for a final check, we need to be making sure we're getting this really, we need to make sure that our results are really good. So to make sure they're really good, we use a quality filter. So in the case, as I showed previously, we've done really well. Our item is an item, our description is a description, our category is a category. We can ask the trained classifier from earlier, do you think this item is an item, description is a description, and so on? In this case, it is. The trained classifier gives us a good score, and we can bypass the typists and send the menu back to the restaurants. However, if we've done badly, so in this case, we've confused the description and the item, we can ask our machine learning classifier, what do you think? And it will say, I don't think that item off the bone is an item. It gives us a bad score, and so we send the menu to the typists. So how does this pipeline do? So we start with 100% of our menus. We lose a small percentage of them to corrupt images, low resolution images that we can't read, and poor OCR results, which generally is bad fonts, strange fonts. Of the remaining 92%, we do excellently on 28% of the menus, meaning that we could send these straight back to the restaurants for a final check. And for a further 15%, we have a good result, which means that we can send this to the typists and they can make us have a substantial head start on typing up the menus. So our final impact is that for 30% of our menus, We reduced the time by 99.7%, going down from 2-hour menu transcription to just 25 seconds. And for our cost, we've reduced it by a factor of 1,000. This algorithm takes about 1/10 of a penny to run for each page. And finally, for the other 70% of our menus, we've removed the other 30% from the queues, and so Jean only has to wait as a reduction of 30% in her wait to get started on the platform. Thank you.